So this is my next video on trigonometry. Prove the identities. Sine cubed of theta over cosine of theta is equals to tan of theta minus cosine squared of theta times tan of theta. So what I'm going to do is to prove the right hand side and show that it's equal to the left hand side. Proof. Tan of theta minus cosine squared of theta tan of theta. Okay, we know one thing, that tan of theta is sine of theta over cosine of theta. Again, cosine squared of theta is the same as 1 minus sine squared of theta. So those two handy identities are going to help us to go about the right hand side. So where we have tan theta, we write sine of theta over cosine of theta minus 1 minus sine squared of theta, and then tan theta is sine of theta over cosine of theta. Okay, so very quickly, sine of theta over cosine of theta. Again, this is a cosine of theta, this is cosine squared of theta, so we can have minus cosine of theta times sine of theta over 1. So sine of theta over cosine of theta minus cosine of theta sine of theta over 1. LCM is cosine of theta, that's LCM between cos theta and 1. So if you divide, you're left with sine theta minus this divided by that, you have cosine squared theta sine of theta. Okay, we want our left hand side to have sine cubed theta there. So this cosine squared of theta, we are going to use this expression. So we have sine of theta minus into 1 minus sine squared of theta sine of theta all over cosine of theta. Okay, so if you distribute, you're going to have sine of theta minus sine of theta minus sine cube of theta all over cosine of theta. Distributing here, numerator becomes sine of theta minus sine of theta plus sine cubed of theta over cosine of theta. That disappears, so you have 0 plus sine cubed of theta over cosine of theta. Okay, and this is sine cubed of theta over cosine of theta. That is the end of proof. Next question, we are supposed to show that tan square of theta plus 1 over tan square of theta is equals to 1 over 1 minus cosine square of theta. So quickly proof. We have seen that tan of theta is sine of theta over cosine of theta. So where we have tan of theta, we'll be writing sine of theta over cosine of theta. So I'm proving the left hand side to show that it's equal to the right hand side. So we have sine square of theta over cosine square of theta for tan square of theta plus 1 over sine square of theta over cosine square of theta. Okay? So our numerator here, this numerator, is sine square of theta over cosine square of theta plus 1. If you take the LCM of these two, you have cosine square of theta as the LCM between cosine square of theta and 1. So this divided by that, you have sine square of theta plus this divided by that, you have cosine square of theta. But we know sine square of theta plus cosine square of theta is a 1, so you have 1 over cosine square of theta. That is what you have in the numerator. Now if you come here, we have sine square of theta over cosine square of theta. We can write numerator 1 over cosine square of theta divided by sine square of theta over cosine square of theta. That becomes cosine square of theta over sine square of theta. That goes, and we are left with 1 over sine square of theta. We're almost there. We know that sine square of theta is the same as 1 minus cosine square of theta. So 1 over sine square of theta is the same as 1 over 1 minus cosine square of theta. And that's it. End of proof. Okay, one more question. 1 over cosine squared theta minus cosine squared theta minus sine squared theta over cosine squared theta is equals to sine squared of theta. Right? So that's what we are going to do. And I'm going to take the left hand side, no matter how complicated it looks. It might be the one which is lesser evil. So let's do. Okay. So we want to be left with sine squared on the right hand side, but everything else is a mixture of cosine squared theta minus sine cosine squared theta. So we have 1 over cosine squared of theta minus cosine squared of theta minus sine squared of theta over cosine squared of theta. So LCM, we have cosine squared of theta over 1 there. So this becomes 1 minus cosine to the 4th power of theta, because the LCM is cosine squared of theta minus sine squared of theta. Okay. So 1 minus sine squared of theta is the cosine squared of theta. So cosine squared of theta minus cosine to the 4th power of theta over cosine squared of theta. If you factor cosine squared of theta out, you're going to have cosine squared of theta into 1 minus cosine squared of theta divided by cosine squared of theta. That and that cancels. So we have 1 minus cosine squared of theta. But 1 minus cosine squared of theta is a sine squared theta. Okay? And that's what we have on the right hand side. We have cosine squared of theta. End of proof. Good. And